Assalamualaikum warahmatullahi wabarakatuh. In this video, our group is having an electrical project, which is camera flash. Before I begin, I would like to introduce myself. My name is Muhammad Hakim bin Muhammad Yusri, and my matric number is 207604. Without further ado, let's get started. The theories that we use in designing the circuit is the natural and the step response of RC circuit. As you can see in the circuit here, this is basically an RC circuit because it have resistor and capacitor. The lamp is only as an indicator, which is represented as the camera flash. The natural response is met by the discharging of the capacitor, whereas the step response is met by the charging of the capacitor. Next, I will explain each of the component, what is the role and function. The first one is here is the DC power. It's basically to provide power source throughout the circuit. The reason we use 350 volt is because that actually camera flash requires a high voltage. It requires a high voltage to do its works. That is why they will have a health problem if they expose too much camera flash, such as epileptic seizures. Next is switch. We use two switch. Actually, we can use one switch, which is SPDT, that is toggle either connect to the left circuit or right circuit. But in this circuit, we only use two. We use two switch because we want to make it closer. So for the left hand side switch is for charging the capacitor, and for the right hand side of the switch is for discharging the capacitor. Next is the capacitor itself. The capacitor is actually an electronic component that stores and releases electricity in a circuit. It is used to generate the flash of the lamp when it releases electricity in a period of the time constant. The next one is the lamp. The lamp, as I said earlier, it acts as an indicator. This is the flash will come out. Okay, that is determined by the charging and discharging of the capacitor's time constant. The next one is both of these. It is called oscilloscope. It is to observe the waveform voltage of the capacitor, either it is charged or discharged. And the last one is multimeter. And the multimeter is the purpose is to only verify the current flow in the circuit after we calculate it in theory.
Results and discussion. When we use the camera flash, it takes a few seconds to charge the capacitor that powers the flash. The camera flash discharges the capacitor in tiny fraction of a second. The flash camera circuit is RC circuit, which is containing a resistor and a capacitor. The capacitor is an electrical component that stores electric charge. The circuit for this project is the RC circuit that employs a DC direct current voltage source, a resistor, a capacitor, and a two-position switch. For charging and discharging capacitor, this circuit allows the capacitor to be charged or discharged depending on the position of the switch. The capacitor is initially uncharged. The capacitor is charged when switch S1 is closed. When the capacitor is fully charged, switch S1 is open. Therefore, close switch S2 then connects the virtual lamp to the capacitor, quickly discharging it, and it will producing a flash.
Assalamualaikum and hi, my name is Muhammad Anwar Hazmi bin Shamsul Ma'arif. My matrix number is 205530. Okay, right now I will explain to you the calculation for this circuit. Okay, as you can see in the diagram, we have the voltage source with 350 volt, and then resistor R1 with 100 ohm, and then two switch, which is S1 and S2. And then we got capacitor, which is C1, and then also the lamp for the output. Okay, for the first one, what is the minimum required capacitance at C1 if 150 joule of energy is required to generate one flash? When the capacitor is fully charged, it acts as open circuit, and the voltage across the capacitor will be the DC source voltage, 350 volt. The required energy to be stored, which is energy equal to 150 joule, and then when capacitor is fully charged, which is voltage capacitor VC equal to 350 volt. By using the formula, energy equal to half capacitor C1 and then voltage of capacitor, which is VC squared. By inserting the value, and then we get the minimum required capacitance C1 equal to 2450 microfarad. Okay, the next one, which is the time for the capacitor to fully charge when it is initially discharged, which is VC1 equal to 0 volt. By using the 3300 microfarad capacitor for C1. Well, approximately, it will take 5 tau time for the capacitor to fully charge, which is time constant T equal to R1 C1. Therefore, amount of time taken to fully charge 5 R1 C1 by getting the values 5 times with 100, which is the resistor value, and then time with capacitance value, which is 3300 micro. And then we get the time taken to fully charge the capacitor, which is 1.65 seconds. Okay, later on, to sketch the graph of voltage versus time for the period between when the switch is changes until C1 is fully charged. When switch is closed at S1 at time t equal to 0, the capacitor voltage gradually being charged for 350 volt, and the expression for the voltage across capacitor as a function of time is given by VCT equal to 350 in the bracket of 1 minus exponent to the power of negative T over R1 times with C1, which is when T greater than 0. And this is the graph for this circuit, which is at 5 tau, the voltage is reached the maximum, which is 350 volt at the capacitor. But then at 1 tau, the voltage at the capacitor is only 63.2% of 350 volt. Okay, last but not least, to find the current that will flow to resistor R1 at instant when the switch closed at S1, when there is no energy stored in C1 before the switch closed. At the instant, the switch closed to S1, since capacitor is initially uncharged, the capacitor C1 acts as a short circuit. Therefore, this is the diagram for the circuit when the C1 acts as a short circuit. The current to resistor, which is R1, by using the Ohm's law, which is V equal to IR, and to find the I equal to V1 over R1. By getting the values, then I equal to 350 volt over 100 ohm. And the result is I is equal to 3.5 ampere, which is current to resistor R1 is 3.5 ampere. Okay, that's all for me. Thank you.